video, and today we have find the number of distinct colors among the balls. And I love these kind of brain teaser questions where it doesn't need a specific algorithm. You could just think of a solution intuitively. Anyways, it says you're given an integer limit in a 2D integer queries of size n times 2. Doesn't matter. There are limit plus 1 balls with distinct labels, like label from 0 to limit. So, like, for example, limit is 4. We have 0, 1, 2, 3, 4. We have 5 balls from 0 to limit. All balls are uncolored. For every query in the form XY, you mark ball X with color Y. So basically, 1, 4, you color ball 1 with the color 4, you color ball 2 with the color 5, etc. After each query, you need to find the number of distinct colors among the balls. So basically, you need to keep track of how many colors exist in this system in general. So thinking about something like this, and it says return a result array where a result of I, the number of distinct colors after the ith query. So after each query, return the result. We need to think about the scenarios that can happen when coloring. So there's two scenarios. The first one is you can color two balls with the same color, right? You can color the two balls with the same color. In that case, the color should be counted once. Also, you could recolor a ball. So a color, you could, like, for example, here, you colored it with 4, and then it came back again, and then you colored it with 3. So we need to get rid of the color 4 because it no longer exists for here, but it exists here. But, like, do you know what I mean? That means the color 4 does not exist because I recolored it, right? So there's two important aspects of this question, right? So intuitively, what I thought of doing was, okay, let's keep track of every ball's color, like every ball's current color, right, in a hash map. And let's keep track of the count of the colors, like how many times does X color appear, right? I count them once anyways, but it's important for me to know the count because if that count reaches 0, I need to get rid of that color, delete it. So these are the basic hash maps I started with. So basically, colors is a hash map with the default value of 0. Ball to color is a hash map having it's supposed to have every ball and its color, right? And then the color count is basically the length of the keys in colors, but instead of having to compute, you'll see the bottom, but instead of having to compute the length of colors every single time, I just like follow them with a counter. And then this is the res I'm going to return. It starts at initially 0, for example, and then we're going to loop over the queries, right? Extracting the ball and the color from each query, right? And then I'm going to check, is the ball in the ball to color? So basically, this means, has the ball been colored before? Anyways, if the ball's been colored before, I'm gonna remove that color basically first, where here I color ball minus equal 1, which is I remove the color, right? So the ball is uncolored now. And then I check if that removal actually made that color 0. If that removal made that color 0, delete it from the hash map and decrement the color count, right? Because that in this case, for example, 1, 3 here, when I'm 1 and 3, the 4 is no longer there after I recolor, so I delete it. Then I actually add the new color, and then I increment that color, right? And then I want to increment the color count once because it's unique, right? So I don't want to count the number of times a certain color appeared. I just want to count it once. So I basically do this case because if colors equal 1, which means if the increment gave it 1, if it was 0 and it became 1, just increment the color count by 1. But if more than 1, don't count it, right? And then I add res to the color count, basically. And yeah, that's basically it. The time complexity is O of n, where n is length of queries. As you can see, this runs efficiently. Yeah, that's been it, guys. Thank you, and see you in the next one.